in a specific range around this base station, or in communication range of the base station, the users or wireless devices can connect to this base station. It depends on the type of technology used in the base station. For example, here you can see we have a Wi-Fi access point. Okay, then you can see blue cloud around this network is small. I lost my connection. Excuse me. Sorry for the delay. Okay, so the communication range in a wireless network, in a Wi-Fi network, is small. It's about a few meters, for example, 30 meters or something like that. Okay, but if I use a wide area of wireless network, for example, a cellular phone technology, we can see that, okay, the communication range in this type of networks is bigger value. Okay, but this base station serves to the connected device inside its cell. Look at this one here, this one here. There are several cells. We have a base station in the center of that cell, and that base station is connected to the wired network, wired infrastructure. Okay. So let me talk about the elements in a wireless network. In a wireless network, as we said, there are several wireless hosts: laptops, a smartphone, IoT, wireless sensors. There are several other elements in a wireless network, and the network applications are run in these wireless hosts. One main note: a wireless host may be mobile, or it may be stationary, not mobile. It's not mandatory that a wireless node has to move. No, it's not mandatory. Some wireless hosts, some wireless nodes can move, and someone cannot. So the mobility does not means, the wireless does not means mobility. Maybe a wireless node is mobile, maybe yes, maybe no. So we should make it clear. A wireless host maybe can move, or maybe not, maybe cannot. Okay. The other element in a wireless network is base station. We talked about base station, and we said that this base station can connect the wireless host to the internet. to a wired network, to a wired infrastructure. Okay, so I can say that the base station is a relay and responsible for sending packet from a wired network into a wireless area, or capturing packets from a wireless area and sending them toward wired networks. Okay, and as I said in chapter 1, in wireless LAN, instead of using base station, I'm using access point. And in cellular networks, I'm saying BTS instead of base station. We call it BTS. In WiMAX, I'm calling base station to that antenna. Okay, and the other main element in a wireless network is wireless link. I need a wireless link to connect a user to the base station. And maybe sometimes I can connect two base stations by a wireless link, using a wireless link. Sometimes, not always. Most of the times we use wired links for backbones as a backbone link, but sometimes, for example, there's an antenna in a big desert. So instead of deploying optical fiber cables, I can use wireless links. It's much cheaper than the optical fiber solution. Okay, so sometimes a base station is connected to internet through wireless backbones, but mostly they connected to the internet via wired links. And when we talk about a wireless link, we should be aware about the physical specification of the link, of the wireless link, because those physical specification can affect the transmission rate and rate of a wireless link. It's we use several different technologies, different physical properties when we work on different distance from a base station. Okay, maybe we use different frequency bands, different technology. So it's not an easy topic. If you are interested to read more about wireless link, you must go to, for example, telecommunication courses or classes. Okay, we talk about some peripherals and properties of antenna design or something like that. Okay, look at this slide here, slide 8 of chapter 7. Here we can see we have different technologies. When we talked about wireless links, we have different technologies. For example, Bluetooth, Wi-Fi, and maybe cellular technologies and something like that here. And those technology has different frequency bands. They has different transmission rates, and their distance, their coverage area, the coverage range is different. For example, when I'm talking about Bluetooth technology, I know that the communication range of Bluetooth device is something about 5 to 10 meters. Okay, and when I'm talking about Wi-Fi, this communication range is something near to 30 meters. But in new series of Wi-Fi, this communication range, when I'm using Wi-Fi as an outdoor implementation, okay, this communication range may be extended to 100 meters. If I use a Wi-Fi technology inside a building as an indoor technology inside the building, its communication range is about 30 meters. But when I implement Wi-Fi technology outside the buildings, or I'm using it as an outdoor technology, its communication range is something about 100 meters. And when I'm talking about, for example, 4G or LTE technology, its communication range is a value between 4 kilometers to 15 kilometers. For 5G, maybe this communication range, maybe it's limited between 200 meters to 4 kilometers. Okay, but look at the speeds. When I'm using a Bluetooth signal, a Bluetooth wireless link, its transmission range is, its transmission rate is about 2 megabit per second. But when I'm talking about 5G technology, the transmission rate is about 10 gigabit per second. Is it only 4G, 5G, and 802.11? What do you mean? These technologies are mandatory in wireless networks. We have several other wireless technologies, name it. For example, for long range, but for long range communication, but with small capacity of transmission, you can use LoRa technology, or instead of using Bluetooth, you can use Zigbee technology. Okay, there are other technologies, but Bluetooth, Wi-Fi, and cell phone technology are dominant in this area, in the area of wireless links. They are dominant. So here we only talk about these technologies. You forget the rest, because, for example, WiMAX is an old and obsolete technology. Okay, and we have one more element in a wireless network, and that element is that may I use an infrastructure in my wireless network or no? So I can divide wireless networks into two separated parts, two separated categories. One type of those network is wireless network with an infrastructure or infrastructure mode wireless networks, and the other is ad hoc mode wireless networks. What is the difference between these two categories? When we talk about an infrastructure mode wireless network, we have a base station, and all of the hosts inside the wireless network, all of the hosts should connect to that base station if they want to talk with other hosts in their networks or outside of their networks in the internet. They have to connect to, firstly, they have to connect to the base station, and then start to communicate with other parties through that base station. And in this case, we have a special phrase, handoff or handover. Handoff or handover. What does it mean? It means that I have a mobile wireless node who changes its base station during his connection. In other words, I have a wireless, or I have a mobile wireless node, okay, and it's starting to talk with someone else. I don't know where. It's not important. Maybe on the internet, okay. It's starting to make a communication with another party, and during this communication, or wireless node or mobile wireless node moves from one network to another network, attaching from the old base station into a newest base station. It means that it changes its base station during its movement while it's still connected. It's still connected to the network. We call it handoff or handover. It's very important in wireless network, especially especially cellular networks, because we have to prepare enough resources for nodes who try to hand over and entering into new networks. Okay. The other mode in wireless network is ad hoc mode. What does it mean? In this type of networks, there is no base station in the wireless network. Okay? We have no base station. And then, if the nodes try to send information, they should collaborate for this communication, collaborate together. It means that all the nodes in an ad hoc mode network acts as a relay, acts as a router, as a wireless router. They forward the packets, receive packets from other nodes in the wireless network. So they just they act as a wireless router. Here, for example, here we have 4 different wireless nodes. They can set up an ad hoc wireless network. They can communicate together through this pass, the passes between them. But look at the node in bottom of this slide. In the bottom, you can see there is a separated wireless node who cannot connect to other nodes. You cannot see the other nodes. So this node cannot communicate with the rest of nodes. It's far away from the rest. So I can say, when I'm talking about ad hoc mode, I can say the nodes in an ad hoc mode network can organize the net in a wireless network between themselves. They can find routes between themselves. This capability is very interesting, especially when we talked about SOS teams or military teams, because we can use infrastructures when we have an implemented base station. We have firstly we should implement base station firstly, and then we can use it as an infrastructure mode wireless network. But for example, after an earthquake, after a big flood or something like that, we lost everything, especially we lost infrastructures. Okay, and at that time we can create an ad hoc wireless network. We can create an ad hoc wireless network, and the nodes around that ad hoc network can communicate together, especially in military tasks in current days. For example, we have some UAVs in the air, some jet fighters, some tanks on the ground, some soldiers, some trucks, military trucks, and something like that. Okay, some AWACS in the sky, and they can communicate together while they are moving around. So they create an ad hoc mode wireless network to communicate together. Okay, so I can create this table here in slide 11. Our wireless network, I can see a wireless network as a single hop wireless network or as a multi-hop wireless network. Single hop means that two nodes can communicate directly, and multi-hop means that two nodes may communicate together via some other parties, some other nodes between themselves. Something like a mesh or VANET or MANET or ad hoc. Okay, and we know that a wireless network may have an infrastructure or may have not. So we have four cases: a wireless network, a single hub wireless network with an infrastructure. It's something like Wi-Fi or cellular networks, 4G, 5G, 2G, 3G, I don't know. They are single hub and they are using infrastructures. And in mesh network, we have an infrastructure, and the network is a multi-hop network, a mesh network. And sometimes we have not infrastructure, such as Bluetooth. In Bluetooth, we have not an infrastructure, and all the communications are single hop communications. Okay, But when we talk about a multi-hub wireless network without infrastructure, we can talk about different types of ad hoc networks, especially MANET and VANET. What is MANET and what is VANET? MANET means that mobile ad hoc network. MANET is mobile ad hoc network. And VANET is vehicular ad hoc network. It's a network between the cars, moving in a street, in a road. The primary application of VANET is safety. When I'm driving along a road, maybe someone takes brake, okay, push the brake pedal, and I need to spend sometimes to see the red light of the car in front of me and processing those red lights in my mind and doing an action, for example, pushing the brake pedal in my car. We call this time as perception and reaction time. Okay, I need this percentage perception and reaction time, which is at least is about 0.2 or 0.3 seconds. Okay, and for example, for a patient driver, this time can be a value of 0.6 or maybe 1 second, something like that. And by this large value of PRT time, we have several accidents. We can see several accidents in the street. So instead of doing everything manually, we can use VANET, for example. I'm pushing the brake pedal, and the VANET network advertise safety messages to the cars around my car, and those cars can understand that I'm pushing the brake pedal, so they can act sooner than a manual braking. If those cars should be intelligent, okay, and they can, using VANET, they can act automatically. They can react automatically against those brakes. Okay, but okay, what is a wireless link? Let me show you some important characteristics of a wireless link. There are several other characteristics, in wireless links, but here we only want to talk about some main characteristics, some main properties. Okay, we just simply want to talk about those main properties. When I'm talking about a wireless network, the question is this: what is the difference between a wireless link and a wired link? what are the main or important differences between them? One of those main properties or differences, main differences between a wired and a wireless link is that when I'm using a wireless link and electromagnetic signals, because I'm sending the signals to the whole area surrounding myself. Okay, I'm sending the signals toward every directions. So we can see that the signal strength will decrease faster than a wired network. In wired links, the signal strength would be decreased, but the speed of this decrease is in wireless network is much higher than a wired link, and sometimes we call it pass loss, because I'm sending signals into an area, into a space that I cannot control it. In chapter 1 we called it guided media or unguided media, and we said that okay, in a guided media you can control the passes toward a destination, you can control everything, okay, but in a wireless network you cannot. So we have pass loss, and the signal strength in wireless networks can decrease faster than a wired network. Okay. The second main differences between a wireless network and a wired one is that when I'm talking about wireless links, different sources of wireless links can interfere the other sources. For example, the Wi-Fi network works around 2.4 gigahertz frequency range. Okay, but if I look on different devices, I can see there are several other devices who works in this frequency band, in 2.4 gigahertz frequency band. So I should be aware about the interferences between different sources of wireless links. The third main properties or difference between a wireless link and a wired one is that when I'm sending information along a wired link, my information has only to pass this specific path of that cable. They just can move toward a destination surrounded by that cable. Okay, but when I'm talking about a wireless one, my information I receive the information. I can receive the information from different passes. For example, I can receive those information directly, or I can receive them while they're reflected by, for example, some by a specific surface, something like that. So multipass propagation is one of the main challenges in wireless nodes. Because different objects in my network can reflect. I can say that making a communication across a wireless link is much difficult than making a communication across a wired link. They are completely different. Because I cannot control the wireless area. I cannot control it. I can completely control a wired link. Okay, I can completely control it, but I cannot control a wireless space, surrounding a wireless link. One characteristics of wireless link is noise ratio, or SNR, or SNR. Look at its name, signal to noise ratio. It's a ratio between the power of signal and power of the noise surrounding my wireless link. And I know that a higher value of SNR makes it easier to understand signals in the destination. Larger SNR makes it easier to extract signals from noise in the destination. Okay? And SNR is a power factor. So if I'm talking about power and something like that, I should be care about the SNR element. And we can compare SNR with bit error rate. Okay, bit error rate, rate of errors in bit error rate. If I increase the SNR of a link, I can say that higher SNR values have a positive effect on bit error rate. Higher SNR, lower bit error rate. Higher SNR, lower bit error rate. Okay. And when we talk about bit error rate, it means that how much of my information received in the destination, how much of my information received correctly to my destination, okay? A larger bit error rate means that I lost most of my information. So it's not a good parameter. I'm looking for smaller bit error rates. And now I'm saying that, okay, with a larger SNR, I can receive lower bit error rates. So maybe someone asked me, okay, so how can I increase the SNR value? Okay, adding more power. The solution is just adding more power. But, okay, so why the operators don't want to add more powers to signals? Why they don't do that? Adding more powers, using powerful signals to overcome noises. Why they don't follow this strategy? The answer is simple. The signals with higher energy, higher level of energy, has bad effects on live bodies, on planets, on trees, on animals, on humans. Signals with higher level of energy. SNR show me the level of energy in the signal. And high level of energies are dangerous for the lives. Okay? So I cannot increase this parameter simply. I should adapt it according to my conditions. I should use the lower value of SNR while still I receive a good level of bit error rate in my communication. So to do that, we use modulation techniques in wireless networks. And for example, here we can see by increasing bit error rate value, we need to move to a stronger modulation technique. And then by increasing the bit error value, again we repeat it. For example, this one here. The green line is stand for CAM 256 strategy, but when the bit error rate is increased, my wireless network switches to CAM 16 strategy. And after that, by increasing bit error rate, we need to change the modulation techniques into, for example, BPSK or binary PSK. Okay. So For example, in bad weather conditions, bad weather condition may affect my wireless link. Water molecules in the air, in clouds, when the air is rainy, cloudy, something like that. Those water molecules can affect my communication link. So simply, I'm changing the modulation technique in my network, and I'm using stronger techniques, stronger but lower stronger techniques with lower transmission rates. Okay, here you can see the capacity of BPSK is 1 megabit per second, while in CAM16 this capacity is 4 megabit per second, and in CAM256 the speed is 8 megabit per second. So by switching between those modulation techniques, I can handle the problem. One more characteristics in wireless links is that if two nodes try to send information together, they should stand in their communication ranges. It means that if I increase the distance between two nodes, after a while, after passing that communication range, they cannot hear themselves. They cannot communicate, make a communication between themselves. Why? Because they cannot receive the signals from other parts, from other side of the network. Or maybe there is an obstacle between them, or maybe their distances are too large. Here in the left side picture, you can see that A and C cannot see each other because of this obstacle, but they can see system B. A and C cannot see each other, but B can see both of them. In this case, if A and C try to send information to B, A and C try to send information to B, they may be collided. Why? Because A and C cannot see each other, so maybe they can send simultaneously. And the result signal received in B is the consequent or resultant of both of those signals from A and C. The signals of A and C would be mixed together, and their resultant would receive to B. Okay? A and C cannot see each other, so they would send information simultaneously, and B will receive the summation of those signals. Okay. In the right picture, you can see A, and there is no obstacle in the right picture. You can see there is no obstacle between A and B and C. Okay, but the distance between A and C is too much, is large. Here, B can see the A and the C, okay? But A and C cannot see each other. Why? Because of the line passes. Look at this red curve or the blue curve. You can see there is a collapse in my link. The signal strength of those red and blue signals decreases fastly, strongly. It's collapse. So C received a weak signal. And if you remember, when I'm talking about wireless network, I said that a signal would received by a receiver would understand it by a receiver when it has a minimum level of power. When it has a minimum level of power. But here, in this case, you can see the signal received to A or C is too weak. Is weaker than the minimum threshold. So A and C would receive the signal, but they cannot hear that signals because the signals are too weak. Those signals are too weak. So it's similar to the past scenario. In the first scenario, I say that okay, A and C are close, but there is an obstacle between them. So A and C cannot see each other. In the right scenario, there is no obstacle, but A and C are far apart, far from each other. So their signals would receive to the other side while its power is very low. Its SNR is lower than the minimum threshold of the receiver. Okay. In this case, we say that this case is hidden node problem or hidden terminal problem. There is no difference between them. Hidden node problem or hidden terminal problem. This concept refers to its strategy. A node would start to sending information to the other side while it doesn't know that the relation between those items. The physical positions. So A and C would send information to B simultaneously, and Again, the result is a consequence of those signals. Okay. By this case, using this case, this okay, wait a minute, please. Okay, is there any solution to solve this problem? Sending two information, two signals together makes a problem at the receiver. Can I solve this problem? Yes. One of the solutions is using code division multiple access or CDMA technology. What is CDMA technology? In CDMA technology, I'm assigning a code, a separated code to each of the users inside the network, okay? I'm assigning a unique code to each of those users inside the network. And those users are shared the same frequency band in the network. But when the users who try to send information to the other side in the network, firstly they should code their data using the received code. Each user has a specific code, okay? So when the user tries to send information, firstly they should code their data with that code and then sending their information to the other side of the network. For example, sending information to the BTS, something like that, okay? In this case, excuse me. Ask me, okay, is there any solution to send information inside a wireless network simultaneously in a similar frequency band? In basic condition, no, because I show you that what will happen in hidden terminal, okay? I cannot send information simultaneously in a similar frequency band. I show you the result. But I need to use something else. For example, I can use code division multiple access or CDMA technology. In CDMA technology, firstly, I'm assigning a special code, a unique code to each of those users inside my wireless network. And then, if each of those users try to send information in the wireless network, firstly, they should code their information using that unique code, the assigned unique code to them, and then they send information over the wireless network. So in this case, I can say, okay, I can have coexistent users who sends information simultaneously in my network. In a similar frequency band. I don't talk about those codes here. There are some special signal encryption, something like that name. Something like encryption. Let me show you an example here. There is a sender and receiver. The sender has two data. For example, the data 1, D0 is 1 and D1 is -1. What does it mean? I'm not clear about the meaning of this information. Okay, I'm not clear. But here, this is my code. It's an 8-bit code. I'm coding this information with this code. The result is here. And I'm coding the data, D1 data, again with my code. Here, you can see I'm repeating the code. My code is fixed, okay? And coding my data with this code. And here you can see the results. I'm sending this information over the network and at the receiver. Again, I'm applying the received data on my code. For example, here, the first bit is -1 and my code is -1. -1, -1, -1, -1, 1, 1, -1, -1. Okay? I'm making an AND, bitwise AND. I'm applying a bitwise AND, one by one. Applying ending bits with similar positions. Okay? And then I'm calculating the summation of them, and finally I'm dividing the result by n. What is n? N is total number of bits in my code. My code is 8 bits, so n here is 8. Here, this data is the summation of this data after AND is 8, and 8 divided by 8 is 1. This is the result. For the next slide, again, 1 time AND with -1, or times 1 times in -1. The result is -1. 1 -1, 1 -1, -1, 1, 1 -1, -1, 1, -1, 1, -1, 1. Here. If I make this sum is equal to -8. I'm dividing it by 8. It's equal to -1. Get this? It's -1. In this case, sum is 8 divided by 8 equal to 1. Get this one? 1. So simply, I decode the received information. Again, by using the unique ID, the unique code. Maybe someone says, okay, let me show you an example of a network with two different senders. What will happen? Okay, here we have the first sender here with special code and sender 2 with another special code. Okay, each sender has its specific code. They are applying those data, their data with their codes, ending, timesing their data, and they send information. But look at this one here. When I'm moving toward the network, inside the network, I can see only the summation of those values. Get this? Two slot summations. How I calculated this one? For example, here 1 minus 1, 1 minus 1. For example, this one, just I'm calculating for the first bit, okay? This bit here. 1 minus 1 is minus 1. Here, 1, 1 is 1. 1 plus minus 1 is 0. And here you can see the result is 0. Look for this bit here. Minus 1 in minus 1, the result is minus 1. 1 in 1, the result is 1. Excuse me. Minus 1 in minus 1, the result is plus 1. And 1 is 1, the result is plus 1. So here, you can see the result is 2. Plus 1 and plus 1. Inside the network, I can see this summation of the signals in my network. But at the receiver here, I'm timesing the received signal with the specific code of, for example, sender 1. I received this special code. Okay, just again, I'm applying the result with this code, and the final result is interesting. Although in my network, I have a summation of both of those here. Both of those. Yes, Naima. This is the last slide. Okay, although inside the network I can see the summation of all signals, but at the receiver again I'm applying the code on the receiver signal, on the received signals, and simply I can decode the primary data of the sender. Here sender 1, and this is the information of sender 1. Okay, we receive this technology, CDMA technology, in some specific types of 3G or 4G networks, in cellular networks. But this strategy using CDMA technology is time consuming, and it uses lots of power, because I should times different bits one by one together and making calculating their summation and then dividing them by m. Okay, I have to put lots of power and energy for CDMA. So only some specific technology in some specific 3G or 4 use this strategy, use CDMA strategy because of its consume powers. Okay, that is enough for today. Is there any question? Have a good day and bye. Goodbye.